Thank you, thank you. So today we're going to be talking about OpenSearch. You could guess, Python and Serverless. My name is Laysa Uchoa. I'm here with
Yuliia Barabash.
And we both are located in Munich, so not so far from here. Some people come from the US to Berlin today. And we both work at a company called NordCloud, that provide cloud solutions for our clients. So let's get started. When we talk about OpenSearch, we talk about databases. And databases are a way that you can store, manage, and retrieve data. But you may wonder why we have so many databases. So every day there is a new database coming up, and there are more than 300 databases out there. And why we have all these databases? We have all these databases because we have different types of data. If you have been in previous talks today, some people talk about the structured data, unstructured data. So that's why for different types of data, you need different types of databases as well. So for example, we have key value databases, graph databases, relational, non-relational, you name it. But let's today talk about something like real scenario using OpenSearch in production. So we started with our client using Dynamo DB to send the data to Dynamo DB, and Dynamo DB was our source of truth. Dynamo DB is a key value database. It's also NoSQL. So it is quite fast. If you want to send this kind of data to that Dynamo DB, it works quite well. The problem could arise when we start to think about search capabilities. So choose the right tool for the job, right? So DynamoDB is quite limited when we talk about search. And one way we could think is like, you don't want to start things from scratch. What you could do is to, if we try to use DynamoDB to search things, we're probably gonna get our clients mad, and we don't want that. So one way we could solve this is actually on top of DynamoDB using something like a pipeline ingestion pipelines that you could use. You could send your data from DynamoDB to OpenSearch, and as you know, OpenSearch expertise is search. So this could help us to actually make our user experience more friendly. But what kind of search problems we face out there? When we talk about search engines, we live in this beautiful world where people talk different languages. I also learn different languages, as I'm not from here. And for example, if you know, in German language, there is something like compound words. What does that mean? This means that two words are actually compound together to become one. So when you say orange juice, it's actually just one word. So if you imagine how this will be indexed and how this will be queried, it's probably different from English language, where these are two words different. So one cool thing about OpenSearch is that OpenSearch is multilingual. So OpenSearch speaks different languages, can help you to save this data in different ways. Another problem that you may find, please believe in yourself. So you may try to read this, and may you understand, I think you will understand. So the same way that you could understand, even if you have a mistypo, search engines can also do that. How do they do that? OpenSearch does that using fuzzy searching. So what does that really mean? It's like looking into the words and trying to flip letters and trying to find relevant results according to how it's configured. This is quite interesting. So another thing that is quite a cool feature is that when you go to a search engine and you start typing things, the search engine kind of understand what are you thinking. And OpenSearch does that. How does OpenSearch does that? Using auto-completion. So for example, if you're looking for funny cat videos, it will try to bring relevant results. And today you are lucky because you will learn how to implement auto-completion in your application. Another thing, if you are coming from a relational database and you are starting to use OpenSearch, you don't need immediately to think about data types. If you work with relational database, you know that could be a big headache to handle all the schemas. But with OpenSearch, you can just send your data, and OpenSearch will figure out that for you. Of course, if you know your data up front, if you know how your data is, it's better to have a mapping in place. Dynamic mapping is called the feature. And as we saw it already in previous talk, one cool thing that OpenSearch has is integration, seamless integration with other databases, that you can send data, bring data, and so on and so forth. And this is one of the powerful features. But we have all these kind of features that solve problems that we have on our search. Today, we're not going to talk about all of them. We're going to be focused on auto-completion. So I will pass by to Yuliia, and she'll show you how can you actually make this in Python.
So hello, everyone, again. And today we will talk about what is auto-completion and how to implement this. Assume you have one great idea. You want to have something like Google search for your website, and you don't know how to implement this. But with OpenSearch, it's very easy to implement. Overall, there's 4 different ways how it's possible to do. 3 of them is done on the index level, another one's done during the querying. 3 of them are search as you type, suggested completion, and edge and grammars, but another one is done on the query level is prefix matching, but today we will focus on 2 of them. Prefix match as the easiest one to implement, and more complicated one is completion suggester, so you will know how to make it more powerful and get all benefits. So let's start with the easiest ones, prefix matching. The idea of this is that you don't need to transform your data. You don't need to come up with special indexing of your data. You have your index. You'll one day, OK, I want to have POC just to try on how my clients will like it, how my users will like it, to have this capability on website. And this can be done by implementing just simple few lines of code. As we Python developer and cloud engineers, we will promote OpenSearch by OpenSearch library. It's a very nice library. It's wrapped around OpenSearch APIs for managing cluster, for managing nodes, for managing indexes, and to do search. For this, you just implement method search, specify the index on which you want to execute your query. After that, you need to specify body for your query, and simply pass the type of the magic what you want to have. For example, it will be, in our case, phrase prefix. We will match the prefix of the phrase. And after that, we specify the field title and query Harry. In a demo part, I will show you this search capability. But after execution of the query, you will receive all documents where title have prefix Harry. It's everything that you need to have for auto-completion, the easiest way. More complicated one is completion suggester. Why it's more complicated one? Because for this, you need to change your index. You need to change how you index your data. It means that OpenSearch create data structure inside cluster during indexing of your data. There's a special type for fields to which you want to create this data structure called completion. And for these fields, during indexing, it will transform to the data structure like a tree. It means, for example, we have a title, field title with a few values. Hello, Harry, and hello, German hello. And during insert, what it does, it will start to build a tree where H will be on the top, and after that, one by one, we'll build the nodes as children to the following letters. And during execution of the query, when you pass you want to search for Harry, what it does, it will first of all start off the top, check the Harry. After that, we'll move on to the next letter, the A, and after that, it will move to R. At the bottom, after end of the analyzing your prefix, it will analyze the rest of the tree and fetch the most relevant results. And for this, we also need to have special type of the query. It's called suggester. that you just specify the query suggest. Inside, you specify the body, name of your suggester, title, because you have to have few suggesters. You can have weights for suggesters, and you also can prioritize them. After that, you specify the prefix which you want to match, and at the end, you just specify the name of the fields that you search for inside. In our case, it will be title. And it's everything what you need to do just to implement simple auto-completion. And right now, let's go to the demo, and we check. So for this demo, we implement a very easy setup. We have simple Docker image, OpenSearch running on local machine. We have simple backend implemented with fast API, Python, and React on the top. And here we have 4 different ways how we can execute our query: prefix matching, age and grammar matching, completion suggester, and search as you type. And in our case, we want to search for movie. And like now we are in Berlin, we want to search for movie with name Berlin, and we can see, okay, Berlin calling, Berlin syndrome, and so on. But there are some people who doesn't know correct pronunciation of Berlin, and they type like Berlin. And this way, we don't get results, because it's the simplest way. We did not implement any additional features. But in case with completion suggester, where we get more powerful setup, and also we implement some fuzzing logic, it means that it's possible in case person mistypes something, OpenSearch will still return on some results, depends of your setup. So in case we type Berlin, we see that we have some matching, but in case we, again, mistype it, called Berlin, it still understands, and still people will get some results. For example, Berlin syndrome, Berlin, and so on. So with OpenSearch, it's very powerful and easy to implement type as you had. Additionally, it's possible to implement this across different indexes and across old fields. There's 4 different ways how you can do this. And according to your scenario, you for sure find the best way. And if we do a conclusion, we can conclude that OpenSearch is very powerful because it has a lot of nice integration with AWS services. For example, pipeline integration between Dynamo DB and OpenSearch, where it's just index your data, and you need to worry to build. Do not need to worry about building additional functionality to get your data from Dynamo DB to OpenSearch. It's super scalable. Also, you can do performance optimization to get the best results for your application. And it's good for data logs, and for analysis as well. And final saying, I believe,
search is equal
to OpenSearch. So if you want to use search, you need to use OpenSearch. Yep.
Thank you. If you have a question, we could take a question.
Anyone have questions?
If not, we can invite you to the own conference.
Yes.
So if you want to give a talk, a short talk in the end of the day, please just think about 5 minutes, 10 minutes, whatever suits you. Please talk with us to sign up for this talk, Lightning Talks.
We'll be doing it on conference at 3:15.
Yes.
So bring your ideas. We want to hear from everyone in the audience. Then we'll vote on who gets to get up here and fire away with their talk.
Woohoo!
Do you have a question for them? No?
Yes. Thank you for your talk. So, in the end, which auto-completion would you choose?
I would choose suggester because it's the faster one. Because of how you store your data so far is the faster one. Additionally, it's possible that it understands fuzzy logic fuzziness. It understands that people can mismatch sometimes their queries, and there's like a low distance between what you return and what people match. So it calculates and returns the best result. So I would use that approach. Exactly.
Any other questions?
Hi. Can you please elaborate on the ingestion part of for the second example?
Yes. So if
how
we
we
check the second example here. So at the current moment, we use integration pipelines between zero ATL pipelines between Dynamo DB and OpenSearch. Is a new feature was introduced a few months ago. Before that, we have some automation to export our data, but right now we use this kind of integration. It's very fast, and I think it's milliseconds when you get your results to OpenSearch. And additionally, you can have nice template for your indexes and map your indexes according to your data as well inside OpenSearch.
Oh, but yeah. So that's useful, but I'm asking about the suggest API. The suggest API, you mentioned that there is some sort of different indexing.
Yeah. So in this case, yeah. So it's data type. So in this case, it's different data type and data type how you store your data, because usually OpenSearch use invert indexes for storing all data and for search. But in this case, it doesn't use invert indexes, but more it's use data structures that's similar to the tree. That's why it's also most of the faster way to search for the data, because it doesn't go to the indexes and match against all indexes, but it's basically go through the tree and search the best results according to your query. Yeah.
Oh, one last question.
So some of this depends upon the analyzer that's used to when ingesting the data, isn't that right?
Yes.
So usually there is either the standard analyzer or some other analyzers. Do you have some recommendations on which analyzer to use for this?
Unfortunately, no. I know that there are special analyzers for acquiring your data, but at the current moment, we use standard analyzer. We still experience to have the best approach as well, but I think it depends of your use case. So far, we use like standard one.
It has worked, yeah.
Yeah.
So one more question. So this one uses a tree, right? I mean, for searching. I mean, that's a little bit less efficient than the standard index methodologies, right? So what is the overhead of this fuzzy matching?
Overhead of fuzzy matching in case we set up fuzzy matching for our. I think we know.
We haven't benchmarked to really tell you the numbers. So it's
we
hard
also
to say.
we don't measure.
Thank you.